To introduce my colleague, Professor HAYTHAM SHEBEL. He is a professor of radiology in Neurology and Nephrology Center, Mansoura University, and he is the General Secretary of the Egyptian Society of Urogenital Radiology. Dr. HAYTHAM is going to speak about numbers in the manuscript. What do those mean? Please, Dr. HAYTHAM.
Thank you. Thank you, Professor Tariq. Thank you, Professor Ragab. Today I'd like to talk about some important concept in the research article, which is the major player for the acceptance of the article and the given a quality measure for the publication. It's related to the statistical concepts. Study design and the statistics, selection of statistical analysis are the major player for the quality of your paper. So it's very important as a researcher to be a good player with them, not make the statistician do all the game. They just should translate your ideas to results, but you are the owner of the research question, you are the owner of the study design. So you should understand very important concepts about the study design and statistical concepts. Today I will focus on just two main concepts, which they are common in analysis for most of the paper, which they are correlation analysis and regression analysis. So start with correlation. What's correlation? Correlation simply the studying of the association or the relationship between two specific variables. One of them is usually the outcome, the other one is usually the predictor or the risk factor. And usually we represent the correlation by a number value. It's called correlation coefficient. So if we have two variables like variable A and variable B, so we have two scenarios. Either first scenario, the correlation coefficient, which is resulted by your output, proves that there is no association or no correlation, so the next step is you should shift to another measure of analysis. And the conclusion say that there is no correlation or association between those variables. The second scenario, you have already association, it's proved statistically, and in this situation you should answer three questions regarding the correlation. Most of the articles, especially I have reviewed many papers, and most of the articles say that there is a significant correlation and stop. However, you should answer three questions regarding this analysis. The first one, what's the pattern of correlation, or what we call the direction of the correlation? Then you should mention the strengths of the correlation, the power of the correlation, and then finally the significance. And this is usually mentioned in the whole paper, but only it doesn't give a sense of your results. So what's the pattern? Pattern, we have two patterns of correlation. It means direction. This is mean that these variables have a positive direction or negative direction. And we will discuss this later. So what about the strengths? Strengths, this is the representation of the coefficient correlation. Coefficient correlation is a number, so it gives you an objective measure. It ranges from -1 to +1. So if you have a value near to -1, so you are dealing with a strong negative correlation. And if you have a coefficient near to the +1, so you have a strong positive correlation. This is very important to interpret in your results. And significance p-value, all of us know it, as long as less than 0.05, so it's okay. 0.05. So if we have no correlation, this means the coefficient will give a result of 0. So 0, it means no correlation between those variables. So, if we have a research question like that, is there a correlation between systolic blood pressure and the age? It means that the age can affect the systolic blood pressure. The age here is a predictor, or what we call independent variable, and the blood pressure is my outcome. I need to check it. So this is an example of the output of these results. We have, this is the systolic blood pressure and the age, and we can check these numbers. This is the coefficients. It's 0.4, and all these zeros indicate the p-value. So we can say there is a significant association between the age and systolic blood pressure. So the next question, what's the direction of this correlation? Is it positive or negative? So if we look at this coefficient, we find that there is no minus sign. As long as there is no minus sign, this means that this is a positive sign. This is a positive correlation. It means that as long as the age increases, there is a prediction of increasing the systolic blood pressure. This is what's the mean by positive correlation. And the vice is true. Okay? So the strength of the correlation here is almost 0.4. It's, we can say it's less than moderate correlation. So we have a strength, and the expression of the strength, it will be subjective. Also, it's important to make a graph visualization of this correlation. And there is a famous plot, graph plot, it's called scatter plot, which is usually the standard graph to represent your correlation. Here we can find that this is a large sample size, over 4,000, is studying the relationship between the age and the systolic blood pressure. So all the dots here represent one of our sample size. So this is over 4,000 dots. So we can say the red line here has a slope trend up. So this is indicate a positive correlation. Also, this is another graph representation between the age in the x-axis and the y, systolic blood pressure. So we can say the trend of the line, which is from blue to the upward. So if we can say that at the age of 40, we can say the systolic blood pressure, it's almost above 120, and 50 age, it will be almost 130, and so on. This is improve what we got in the statistical analysis. So it's important to express your results by statistical numbers and by the graph visualization. If we take another example on the other side, what's the effect or what's the relationship between serum creatinine and estimated GFR? This is the output, and we can notice that this is a minus sign. This is indicate that there is a negative correlation. And this is the coefficient. It's almost 0.8, so it's almost near to the +1. So this is a strong correlation, and in the same time negative. It means that as long as serum creatinine increase, we can expect that GFR will decrease. And this is a physiological point, all of us, we know it. So this is the value of a correlation. And this is the graphical representation of the same side. This is the negative correlation, the trend line in the opposite direction of the positive, and this is the scatter plot, which represent this pattern. And all these patterns of correlation, we can summarize in this graph. As long as the dots near to the line, this means that we have a strong correlation. And if the dots away, so we can say there is a weak correlation. If we have a random dots like that, there is no specific trend, so we can say there is no correlation. It will be manifested by the results. Most of the paper stop at the correlation, and even if they mention the 3 points, it's good, but the correlation, it should be the first step for a next logical step, which is regression. Regression gives more insights for your data, and it's very important. We call it the prediction analysis. It can predict many results from your data, so and give more insights for your data. And also we have a regression coefficient. So It quantifies the expected outcome, and we have two types of regression. What we call linear regression and logistic regression. The linear regression gives predicted values, predicted numbers. However, the logistic regression gives predicted percentage, predicted probability. So if we take an example of this, of the same question, is there a correlation between the age on the systolic blood pressure? We already have the answer, yes, it's a positive correlation. This is the coefficient of the regression. This is as significant as the correlation presented before, and this is the coefficient. It doesn't indicate the strength, but indicates how much the systolic blood pressure will increase regarding to the age. If we interpret this result, I can say every 1 year, the systolic blood pressure increased by 1.02 millimeter mercury. So the regression gives another insight for our analysis. It gives a prediction, accuracy, how much will increase the systolic blood pressure. And also, we can make a prediction for any age. I can estimate or predict the age of a subject with 80 years or 70 years. I can say exactly what the blood pressure will be, or what the blood pressure will, how many increased by millimeter mercury. This is an example of the other type of logistic regression, with the gender. There is difference between the gender, male and female, on the systolic blood pressure. This is another direction of your data. If we can see the coefficient here, the male 2.08, and it is a significant correlation. So what's mean by 2.08? This is mean that as long as the patient is male, it will be higher, 2 millimeter mercury, than females. So all these insights, it's very important to browse it because it's already in your data, but you don't know about it because you give the control of the data for the statistician only. But you should direct the statistician to what you need, what you will need to present. So don't lose your valuable results because you don't know, okay? So this is example of logistic regression. So we can know there is a difference between the gender, between the male, has a difference, a power of systolic blood pressure compared with females by 2 millimeter mercury. Another example for odds ratio, what's the effect of diabetes on the events of stroke? If the patient is diabetic and the patient not diabetic, what's the probability to have each group of stroke? We have here the odds ratio. Odds ratio here say that the diabetic patients has 3 folds to have a stroke compared with non-diabetic patients. All this information you will not get it except with regression. So we say that regression is the next logical step for correlation analysis. This is another effect or research question. What's the effect of gender on the stroke? We can say that this is 0.9, almost 0.9, but we cannot say that there is no significant. So it's by chance we can rely on this association because it's not significant. However, if we like to interpret these results and it was significant, I can say being a male has a probability of 12% reduction to have a stroke compared with females. So this is the importance of our odds ratio and the logistic. And in summary, correlation and the regression analysis are linked to each other. You should start with the correlation and then continue your results by continuing the regression analysis. Regression analysis has different patterns, should understand it, could be logistic regression or linear regression, and every pattern has a meaning and it can give another concepts of your results. Coefficient of correlation are similar but not the same. Correlation coefficient gives the strength of the relationship, but the regression coefficient, it gives you a predicted examples, a real examples of your data. And thank you.
Thank you, Dr. Hassan, for the excellent presentation. We'll keep the question till the end. Now I am honored to introduce Dr. Tariq Das.